Second way to determine the probability is to approximate the probability of an event A by making many observations and counting the number of times that it occurs. This approach is called the relative frequency method or empirical method. So let me write that out. Relative frequency method. Okay, so let's take a look at that. If you're interested in only number of heads when tossing two coins, the possible events are 0 heads, 1 head, or 2 heads. Suppose you repeat a 2-coin toss 100 times and your results follows. So in other words, I've gone out and I've done the experiment, and I'm going to record out of the times I did it a certain event. Let's see, compare the relative frequency probabilities to the theoretical probabilities. Do you have a reason to suspect the coins are unfair? Okay, so we're going to kind of think about what should have happened and if we suspect there's some sort of issue. So let's see, this is of the relative frequencies, so this is the empirical data, meaning we went out and did it. Okay, we did it 22 out of 100 times for 0 heads, 51 out of 100 for 1 head, and 27 out of 100 for 2 heads. And decimal wise, it works out to be about 0.22, 0.51, and 0.27. Now, is that scandalous or not? Well, if we go back to our theoretical, so we kind of did this earlier, there were 4 possibilities. So tail, 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 head, head, tail, and head, head. Okay, were the 4 different ways it could show up. So I would expect 1/4 or 0.25% to be 0 heads. I'd expect 2/4 or 0.5 to be 1 head, and 1/4 or 0.25 to be 2 heads. Now, when I compare those numbers, they're pretty close. So do I suspect that there's any sort of cheating or anything unfair going on? Not really. Looks like everything's on the up and up as far as this is concerned. All right, when we talk about probability, we've got 3 main approaches to consider. We've got what's called the theoretical probability. That's sort of pencil and paper, what we expect to happen out in the real world. We've got a theoretical probability based on assumptions that all outcomes are equally likely, dividing the total number of ways an event occur by the total possible outcomes. We've also got something called a relative frequency probability. This is based on observations or experiments. So we actually go out and do the experiment and see what happens. And the third one, and this is unfortunately what most of us are guilty of, this is called subjective probability. This is not based in fact. This is not based on observation. It's based on experience and intuition. It's what we think. It's our gut. What does our gut tell us? Which does not necessarily mean it's an accurate reflection as to what's really happening. Okay, so let's practice identifying the different types of probabilities from the description. Statement A, I'm 100% certain you'll be happy with this car. Okay, so I've said a number. I've used probability words. So 100% probability means it's a guarantee, it's a certain outcome. However, do I have any evidence? Not really. It's kind of even hard to say that at all. So that's just based on what I think. That's subjective. Based on government data, the chance of dying in an automobile accident during a 1-year period is 1 in 8,000. Well, they did an experiment. They wrote down how many times something happened. So that's that empirical or relative frequency. Probability of rolling a 7 with a 12-sided die is 1 out of 12, and they didn't actually go out and roll the die. They just looked at what would happen assuming everything is possible, that all outcomes are equally likely. So this would be theoretical probability. Okay, if the probability of event is probability of A, then the probability of event does not occur is 1 minus the probability of A. They actually call its complement. Complement, by the way, is that sounds like I'm saying something nice, like, oh, you look nice today. But in a probability standpoint, complement simply means it's 1 minus the probability of an event. So an illustration of this, since the probability of a family of 3 children having 1 girl and 2 boys is 0.375, what is the probability of having 3 children that don't have 1 girl and 2 boys? So probability of not having 1 girl and 2 boys is 1 minus the probability that they gave us, which in this case is 0.625. All right, A blank represents probabilities of all possible events. That's kind of silly. A probability distribution, the word's right underneath the blank. Probability distribution so in other words, is we write out all the different possibilities that could happen. So we listed all possible outcomes. Sometimes a table or some sort of organizational method is nice. Identify outcomes that represent the same event. Determine the probabilities of each event. And the sum should equal 1. Okay, this is a very classic probability distribution that students, I think, should just know from the start. What are the possible outcomes when we look at the sum of 2 dice? Okay, so I'm going to start writing this out. Eventually you'll recognize the pattern and kind of beat me to the punchline at the end. But I could roll a 1 and a 1, or a 1 and a 2, or a 1 and a 3, or a 1 and a 4. So these are, if I roll a 1 on the first die, what do I get on the second die? Okay, I could have rolled a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4. Okay, could go a 3. And hopefully you're going, hey, wait a second. I know what's going to happen. We get this nice, lovely chart that lists out all the possibilities when rolling 2 dice. Sorry, not 4. That should be a 5. 1. And then one more row. Okay, so this little chart here is a nice, easy way to organize all the different possibilities of what could happen when we roll 2 dice. Now, interesting pattern. We're going to look at the sum. So if I add 1 and 1, I get 2. If I go 1 plus 2 or 2 plus 1, I get 3. So these are the sums of the 2 die rolls. 1, 3, 2, 2, and 3, 1 all add up to 4. Notice the pattern yet? 1, 4, 2, 3, all of this row, diagonal, all of that diagonal adds up to 5. Here, if I did this right, we get 6. The biggest row gives us 7. This row gives us 8. That row gives us 9. That row gives us 10, 11, and 12. So those are all the different sums that could have happened when we're rolling a die. Okay, the odds are the ratio of the probability that a particular event will occur to we're going to talk about that too a couple different ways in a moment, to the probability that it will not occur. So we have something, the odds for an event, which is the probability of A over the probability of not A. We have odds against, and it's just reverse of that. So probability not A over probability of A. Again, it's just a fraction that we're using this. So in gambling, when we say odds, generally that means odds against. So it's nice they do that, but so out in the real world, when you hear, what are the odds of this? You're usually against something, not supportive. It's kind of interesting. All right, what are the odds of getting 2 heads in tossing 2 coins? What are the odds against it? Okay, so we want odds for getting, so odds of getting 2 heads versus odds of not getting 2 heads. Okay, well, if you think back to our little experiment before, we had 0 heads, we had 1 head, and we had 2 heads looking at coins. So this was 1, 2, 1. One way that we could have 0 heads, 2 ways we could have 1 head, and 1 way to have no heads out of 4 total. So the probability of getting 2 heads would be 1 out of 4. Probability of getting not 2 heads would be the others, so 3 out of 4. Now if you remember your fraction rules, when you divide by a fraction, you're going to multiply by its reciprocal. The 4's divide out, and we're left with 1/3. So the odds of getting, odds for getting 2 heads is 1 out of 3. So odds against, okay, this would be 3 out of 1. So 3 to 1 odds against. In a horse race, the odds on Blue Moon are given as 7 to 2. Okay, 7 to 2 simply is that we can set that up as a fraction, or we can leave it the word 7 to 2, or another way you'll see it written as 7 with a colon 2. If you bet $10 and Blue Moon wins, how much will you gain? Okay, so a little understanding of what the gambling rules are. So 7 to 2 odds means that for each $2 you bet on Blue Moon, you win 7. So if I bet 2, I win 7 back. A $10 bet is equivalent to, $10 is equivalent to making 5 $2 bets. So that means I would win 5 times the 7, so I'd get $35. It turns out we also get the money we bet back, so we'd also get the $10 back, the total of $45. I think the best way to avoid this type of math is just not to gamble, and then it's a non-issue. But if you want to know how that works, there you go. Those are the rules.